This video is about how arrays or lists are made in a language like Java, and how is it that a language like Java can have you create a list, an array list, and have it be dynamically in size, right? It can be 5 places long or 10 places long. It can be dynamically allocated. And just to show how it happens, I have here a C program which makes an array. However, in C, the array has to be allocated at compile time, I think. So we can see here on this line of code here, we initialize an array of 5, right? And we of course have our pointer to the array. Now in C we can make an array of 5, and it has to be of size 5, no larger than 5. We can't just add elements to the array or assign values inside the array that are outside of the bounds of the size of the array. However, the way you can allocate more memory for the array is by using, first you allocate the memory with malloc here, but then you can eventually resize, right? Resize the dynamic array to a new size with realloc. And then we can, so I'm going to go ahead and run this. Just clear this and run it. Clear and run it. Right, so this is our first array, right? It's size 5. However, of course, after this reallocation, right, we can make new indexes and have a new array size here. And what we do is we, to reallocate, we take the, maybe I can do this here. Yeah, it shows some information from the manual here. Yeah, in NeoVim you do Shift K to open the documentation. But yeah, it takes a void pointer and the size t, right? So we realloc, so we take the dynamic array and we tell it that we want a new size, such as 10 times the size of the type. The size of the type comes from up here where I declared the size of the type is int. It's an int array. And so that's how it has to be done in order to take a normally sized array. Normally we can only have a size of array of 5, but if we want to increase the size, we need to reallocate memory. We need to just assign more memory to this dynamic array. And that would give us the luxury of having an array go from 5, a size of 5 like this, all the way up to maybe a size of 10 like this. And then you should like free the memory after it seems like you're done with using it. So a language like Java has this. This is some documentation about Java here. Right, the list in Java. So it says here Java list is an ordered collection. Java list provides control over the position where you can insert an element. Now it doesn't really say it right off the top, right in the first paragraph, but you can increase the size of a list in Java, right? So when you create an array list with Java, such as here, you don't really tell it how large the list will be, right? You can just keep adding elements to it. So here's very similar code for a dynamic array list with Java, right? And we're going to have something very similar to what we had with C. Although here we can just simply add elements to it. And then we'll print out this array list with 5 elements. Then we'll just decide that we want to add more elements, right? And all we have to do is just do dynamic list.add. So I could try to run that program. Right. So it's very similar to what we had with C, where we go from having a list of 5 to just having a list of 10. In Java, all we have to do is call this method dynamicList.add. And you could imagine that so-called under the hood at a more low level, it's doing something more like this, where it's allocating more memory to it. So Java is using an array. Java is using an array just like this. However, it's doing an allocation for you, a reallocation for you, for more memory into the array. And it's making it look all nice and tidy with this declaration up here of list. So when you use ArrayList with Java, it will give you access to these methods like add, which will help you just allocate more memory for the array. So I hope that gives you a better understanding of how Java, a language like Java or Python, where we have these lists, how is it that you can just simply add elements to a list and it just seems so effortless? Well, it's using under the hood a more verbose process, such as what you would see in C, where you allocate more memory to the list if the code demands it. So if you like this video, please like and subscribe, and happy coding.